Hello and welcome to helpyourmath.com. In this video, we're going to look at examples of expanding logarithmic expressions. And before we get started on that, let's just review the three properties of logarithms that will be used or implemented during this video. First, we have same base multiplication. So with same base multiplication, what we're talking about is if we have log base b of x times y, we can rewrite this as log base b of x plus log base b of y. Because remember what x and y are, they're like exponents of some base b. And what do we do when we have a base and the same base and two things being multiplied? We add the exponents. So that's basically what we're talking about with same base multiplication. For same base division, what we're looking at here, and again, this is what if we have an exponent or a base with an exponent divided by the same base with an exponent, what would we do? We would subtract the exponent. So that's exactly what we do here. Log base b of x minus log base b of y. And lastly, if we have power to a power, so if we have a base with an exponent and then we have a power outside of that, what do? We multiply the powers. That'd be something like this. We multiply the powers. This one's a little bit funky. What we do is we take the power of the argument and we write it as a product, so become y times log base b of x. So we're multiplying the powers, which seems a little bit wonky, but that's what we do. And just to review the terminology, b here is called the base, and whatever's inside the logarithm is called the argument. So I use those words a lot, just to review those. I didn't go super into detail about these. There is another PowerPoint. I didn't go into too much detail with these, and that's because there is another YouTube video where I do go into more detail and kind of explain these a little bit better. So if you need to, go back and watch that. Now let's look at some examples. We're going to expand each expression as much as humanly possible using the three properties that we just discussed. Now what that means is that every argument is just one single term. No exponents or exponent of 1, not two factors, just one single factor with an exponent of 1. Okay. So how are we going to expand this? We're going to use those properties. So I see we have three different bases. There's base b in the numerator, base c in the denominator, and base d in the denominator. So the first thing I might do is just separate those. Now I do have to be careful with two bases in the denominator because basically what that means, so I'm going to start with the base 5. Anytime there is a factor or a base in the denominator, there should be a subtraction sign in front of that, indicating that subtraction sign indicates that it's in the denominator. So some people say, but these are being multiplied, so we should add them. And you're right. If you want to add them, then what you do is you need to put them in parentheses, or in this case, I'm going to use brackets. So then if we were to add them, we would say, okay, in the denominator, we have log base a of c cubed, and we have log base a of d. But then we probably want to distribute that subtraction, and so ultimately they both end up getting subtracted. So just keep that in mind. It can be a little bit tricky when there's multiple bases in the denominator, but anything that's in a denominator should have a subtraction sign in front of it. Okay, while I'm distributing the subtraction, I'm also going to take care of the fact that we have exponents in our arguments, right? So the exponents come out and they become coefficients. So we get 5 times log base a of b minus 3 times log base a of c minus log base a of d. Notice that each argument has exactly one factor going on and it has an exponent of 1. This indicates to me that we are fully expanded. In our next example, we have log base u. Okay, the first thing I want to do is I want to actually clean up the fraction a little bit, the argument. I want to distribute that cube. So we're going to say log base u of a to the 6th b cubed over 8. I want to make sure that everything is separate, right? So we have a base of a, we have a base of b, separate those. Make sure they're not in parentheses with each other. Distribute, distribute, distribute. Okay, so now let's split up our three different bases. So I'm going to write this as log base u of a to the 6th plus log base u of b cubed. That 8 is in the denominator, so there should be a subtraction sign in front indicating it gets moved to the denominator, log base u of 8. Now let's clean this up because I still have some arguments that have exponents that aren't 1. This will become 6 times log base u of a plus 3 times log base u of b minus log base u of 8. And that is fully expanded. I encourage you to pause the video and try these three on your own and then check back with me and I'll discuss them. Okay, for the first one, what do we need to do here? We have log base 2 and we have all this stuff going on. Well, we need to distribute the radical in the numerator. So I'm going to rewrite this first and foremost as log base 2 of the cubed root of m times the cubed root of n. And then this is going to be over the 5th root of p squared. Now what we want to do is we don't want radicals. Radicals are still not okay as arguments. So we're going to rewrite the radicals as exponents. Do you remember how to do that? So if we have an index of I and we have something under the radical, this becomes x to the 1 over n, right? So the index becomes a part of the exponent. It becomes the denominator of the exponent of the base. So then let's rewrite it as m to the 1/3 times n to the 1/3. And then in the denominator, we already have a p squared, so that 2 is the numerator. The denominator would be 5p to the 2/5. Now we're ready to expand as much as humanly possible. So each factor gets its own separate logarithm. So we're going to have log base 2 of m to the 1/3 plus log base 2 of n to the 1/3 minus log base 2 of p to the 2/5. Okay, one more step because we don't want our arguments to have exponents. So we're going to pull those exponents and write it as the product using the power to a power property. That's going to be 1/3 log base 2 of m plus 1/3 log base 2 of n minus 2/5 times log base 2 of p. And there we have it, fully expanded. All right, our next example, it looks like they're already separated for us, so that's good. What I will do is rewrite them as exponents, the radicals. So this will be log base n of a to the 5th. Here we have an index of 4, so this is going to become b to the 3 over 4. And there's no index. When there's no index, it's assumed to be an index of 2. So this will become c to the 1/2. Okay, now we're ready to separate. So we get 3 separate logarithms, one for each factor. So we get log base n of a to the 5th. And we want to be careful here. Any factor or any piece of the argument that's in the denominator should come after a subtraction sign. So we're going to get log base n of b to the 3/4 minus log base n of c to the 1/2. Notice when I separate the argument into separate pieces that the base is always the same. So the base stays the same whether they're condensed or whether they're expanded. And last but not least, let's get those exponents as coefficients. So we get 5 times log base n of a minus 3/4 times log base n of b minus 1/2 log base n of c. Our arguments are all single factors with exponents of 1, so we're good to go. Okay, in our last example here, we have log base 3 of m plus n times 9. We're going to keep those separate, so we have 2 factors. We have n plus n, and we have 9. That n plus n is one single factor. We can't separate those no matter how tempting it is, especially when we see that plus sign. It's like, well, we can just write them as 2 separate arguments. No, you can't. That is one factor. It stays together. So we're going to separate this. We're going to get log base 3 of m plus n plus log base 3 of 9. And that looks like an h. I'm just going to fix that. Okay. And now there's no exponents, so we're good there. However, this could be simplified, right? This is log base 3 of 9. That's saying 3 to what power is 9? And that's something that we probably know. That ends up being just 2. So we can rewrite this as log base 3 of m plus n plus 2. Notice that when we perform the operation, we perform the logarithm does go away because we did that operation. So it just becomes just a regular 2. These have been examples of expanding logarithmic expressions. Thank you for stopping by.